Our essential question in this video is, what are the properties of tangents and circumscribed angles? If you remember in one of our first videos on our definitions, we defined a tangent as a line that touches a circle at only one point. So we're going to be talking about the properties of tangents, and then a circumscribed angle. Remember, inscribed meant inside of a shape. Circumscribed means outside of a shape. So a circumscribed angle is an angle that's formed outside of a circle. Let's take a look at our first section here. You see this circle? We're going to go ahead and draw a couple things here so we can talk about the properties of tangents. The first thing I want you to do is take your straight edge and see if you can go ahead and draw a line that is tangent to this circle. We're going to go ahead and put arrows on it to symbolize a line, and then we're going to go ahead and label a point right here, which is point A, and let's label this point right here point B. Try to make that point right where it looks like that line is going to just barely touch that circle. And then let's take a look at the prompt below as we continue. It says, if line AB is tangent to circle C, and we drew a line AB that is tangent to circle C. Let's go ahead and label this circle C. And CB is a radius. So let's go ahead and draw a line segment from point B down to the center of the circle. I'm going to make that a dashed line. If you would do the same thing, just so we can see clearly there, that line is different than the tangent line. But if we have a segment CB that is a radius, so this is from the center of the circle to a point on the circle, and the point on the circle happens to be point B, which is where the tangent line touches the circle. If those two things are true, then angle CBA must be a right angle. Let's label that as a right angle with a little square right here. Not a very good square. Let's try it again. So what we're learning here is, if you have a radius that touches the circle at exactly the same place that a tangent line touches the circle, those two lines, CB and the line, the tangent line, they must meet at a right angle. And this point B, make sure you understand this, this point B is called the point of tangency because that is where the tangent line AB touches the circle. So it's an interesting property of a radius and a tangent line to a circle. Let's take a look at the next section. For this one, you got to do a couple more line drawing, a couple more lines to draw here. Let's put this one down here on the bottom. Again, we're going to create what appears to be a line or a tangent line. And if you would, go ahead and put arrows on the ends of that as well. And we're going to label the point of tangency here as C. Let's label another point on this tangent line. We'll label that B. And let's label the circle A. Let's call this circle A. And the same thing we did before, let's go ahead and draw a radius from the center of circle A to where it touches the point of tangency. And I'm going to go ahead and make that a dashed line again, if you want to do the same thing on your drawing. And then one more thing, let's go ahead and connect. Let's connect, I'll use orange. Let's connect point B to point A. All right, now let's take a look at what our prompt in our box says. It says, you can prove whether a line is tangent or not by using the Pythagorean theorem. So think about this, class. We just learned in the previous box. If you've got a tangent line and a radius that touches the circle at the point of tangency, that must be a right angle. So therefore, if line CB is tangent to circle A, this angle ACB must be a right angle. If it's not a right angle, then I guarantee you that this line CB does not touch circle A at only one point. It might not touch it at all, or it might just go slightly inside the circle, and it might touch it at more than one place. So we can prove it's tangent by using the Pythagorean theorem. Let's go ahead and label with small letters here Let's label this small lowercase a, and this is lowercase b, our radius. And then I'm going to go ahead and label this right here between point A and point B. I want to make sure you clearly see that I'm actually showing you the entire length of that line segment. So we're going to go ahead, let's see if I can do this. You can do it a little easier than I can. We're going to draw a little box there, or a little ending point there. And you're going to see that we're going to label this distance from A to B. That's going to be lowercase c. The reason I'm doing that is because if I don't do that, you might not know whether I'm just talking about from A to here or from here to B. This tells you that this letter C is the length of segment AB. So here's what we can show. If a squared plus b squared, a squared plus b squared equals c squared, then line CB has to be a tangent line to circle A. And the opposite is also true. If a squared plus b squared does not equal c squared, then line CB is not tangent to circle A. So we can use this Pythagorean theorem to verify, is a line tangent to circle or is it not? If it makes a right angle right here, then we know it is a tangent line. If this is not a right angle, meaning this is not a right triangle, then it is not tangent, and the Pythagorean theorem will not be true. Okay, last thing on here, we'll apply this in worksheets in class. Last one here, what about if we make two tangent lines? Let's go ahead and do that right now. So I'm going to create a tangent line somewhere around right here, and I'm going to do another one somewhere right here. Use your straight edge to go ahead and do that. And let's go ahead and label our points of tangency. We'll call that point B, and we'll call this point of tangency point C. And let's call the intersection of these two lines, or these two tangents, A. And then, like we did before, let's go ahead and draw a radius from the center of this circle to the tangent point B, and another one to tangent point C. And again, I'm going to make those dashed lines. Those are a radius of the circle. And let's do this one more, make this one a dashed line. You can do that yourself as you're drawing them. Okay. Now here's what we're looking at. Quadrilateral ABCD. Let's go ahead and label the center of the circle D. Quadrilateral ABCD. If you see class, or ABDC, you can see, actually, you know what? If it's called ABCD, I'm going to have to label this different. Let's do this. It's going to have to be ABCD. I'm going to have to label that in order. ABC, and then this is D. Okay, is formed by two rays tangent to circle C. So there's my two rays. I'll put some arrows there so you can see those just continue on. And a central angle formed by the points of tangency. So take a look. We've got a central angle right here, BCD. We're going to label that angle, angle 1. And let's label this one out here, angle 2. Now notice we've got a quadrilateral. It's not a parallelogram or a square or a rectangle, ABCD, but it's definitely a polygon with 4 sides. Now look at the property of this. Since the angles of a quadrilateral always add up to 360 degrees, and we know that angle CBA, we know that has to be a right angle because this is a tangent line, AB, and BC is a radius, they make a right angle, and we know that CDA also has to be a right angle because AD is a tangent line and CD is a radius that touches at the point of tangency. We know those are right angles. If those are right angles, they're both 90 degrees. That means if we take 360 degrees and we subtract these two angles, 90 and 90, that leaves us with 180 degrees. And that tells you that angle BAD, this angle 2, and this angle 1, they have to add up to 180 degrees. If you think about this again, if this is 90 and this is 90, those add up to 180, If the four angles of a quadrilateral add up to 360, that means we have 180 degrees left, and that means these two angles have to add up to 180 degrees. So there are three properties of tangent lines, or tangent rays or lines, and we're going to be using those in worksheets to solve for missing angle measures, or we're going to also be using them to prove that a line is or is not tangent. One more thing, class, I forgot to add on this drawing. This angle number 2 right here, you want to go ahead and label this. Actually, it probably can fit it right here in the box. Let's make sure we label this angle so we know what it is. Your essential question said circumscribed angles. This angle 2, this is what a circumscribed angle is. So you want to put a little notation here. Angle 2 is a circumscribed angle. If I can actually fit this in here, and sorry I'm rushing on this, so I'm making mistakes, is a circumscribed angle. Remember, circumscribed, again, I was talking about this in the beginning of the video. It's something that's outside of a shape. So this angle is outside of the circle, so it is a circumscribed angle in relation to this circle.